Okay. Now, the first topic is the states of matter. So before going to detail in state of matter, you should know what is a matter. The definition of matter, we are taking it from the beginning. So it is say that anything has mass and take up space, that is known as matter. Other words, we can say everything around us is made of matter. So in simple words, we can say anything has mass and takes space. Sometimes instead of take space, they use the word volume. That anything has mass and volume, that is known as matter. So matter is made of a tiny particle. They said that, for example, this is the matter. If you want to see the detail that this matter is made of what, so you will find that at this is made of very small and tiny particles. Like the in biology, the every organism is made of cells. The unit of the organisms or human body is a cell. In the same way, if you will take a matter and you start to divide this matter into smaller parts, for example, this part, divide it further, more smaller, then more smaller. So one point will come that you cannot divide that particle further. So that tiny particle is known as an atom. So the matter is made of very tiny particles, and that tiny particle is known as atom. So we will see, you can say this one here. And sometimes they use the word atom, sometimes they will use the word particles, okay? Sometimes they use the words ions, sometimes they use the words molecule. So now we'll take about the atom. So matter is made of very tiny particles, and that particles are made of atoms. So now we will see the different states of matter. Now they're saying that, okay, now everything that is made of matter. So we saw that one. For example, now we said that these are the small particles, they are known as atoms. Now, the same atoms, sometimes we call them solid, sometimes they are known as liquids, and sometimes they are known as gas. The same atom, so why they have different states? So there are some factors which will decide that now these atoms they are known as solid, and these atoms now known as liquid, and they're known as gas. So these three different states are known as states of matter: solid, liquid, and gas. There is another state, the fourth one, that is known as plasma state, but that's not in your syllabus. So you will just focus on these three. Now, why the atom they are known as solid, why the atom they are known as liquid, and why the atoms known as gas? So if we want to study, so we have to take help of their some properties. For example, if you talk about the atoms, the same atom, if the atom in solid, the same atom in the liquid, and the same atom in the gas. For example, solid, I can say ice, liquid, I can say water, and gas, I can say steam. If you talk about the type or nature of the particle, nature of the atom, all of them, they are made of the same type of atoms. But then why it is known as ice and it has different properties, and why it is known as liquid water and it has some different properties, and steam has some different properties? So we'll see them. So if we talk about them, we will see this heading. Number one, distance between the particle. In solid, these atoms, they are closely packed. In liquids, packed closely, but still they have small gap between them. In gases, these particles are far away from each other. So if I want to make the diagram, so I can make the diagram like this. For example, in solid, they are closely packed. If I talk about liquid, I can draw like this. There are small gaps I can say between them. But in gases, they are far away from each other. Number two, arrangement of the particles. Here, regular. Regular means they have a pattern. But here, random. Maybe you'll find like this, then you can find like this, like this, like this. They are not a regular arrangement. In gases, also random, the particles can arrange themselves by any mean. So this is the main difference between the solid, liquid, and gases, the how the particles are arranged there. After that, the heading which we will see, that is the attraction between the particles. If you talk about the particles in the state of solid, they are really strong. The force of attraction between two particles or two atoms, they are really strong. If you talk about liquids, so they have the force of attraction, but it is less than solids. Then if you talk about the gas, they have very weak, or sometimes you can say no force of attraction. So this is the force of attraction between the particles. Please, are you getting this one? Please confirm.
Yes.
Yes, Ahmed, other Ahmed, are you getting this one? Please send a message. Then okay, thank you. Then we have the movement of the particles. The particles or atoms in solids, how they move. Particles can vibrate around their fixed position. For example, if you have an atom in solid, it can just vibrate. It can come here, but again it will come back to its original position. But if you talk about the liquid, so particles can slide and slip over each other. For example, particles here, one particle here. So maybe this particle can move and it can come here. So in liquids, particle can move from one place to another. And if you talk about the gases, they are really free. They are in random motion. At any time, they can move in any direction. So that motion is known as random motion. So if you talk about solids, they can vibrate only about their fixed position. In liquids, party can slide past over each other in a random motion, and in gases also they have a moving randomly. Volume. If you talk about the volume of solid, it is fixed. If you will take this solid at any place, so it is fixed. If it is, for example, I will say you have one solid particle. Let's say this is a solid particle, and now its volume, you found its volume, let's say it is 6 meter cube. So it will remain 6 if you will keep it inside the room, if you keep it outside the room, wherever you will take, its volume will remain fixed. Volume of the liquid, it's also fixed. For example, if you have 1 liter water in a glass, now it is 1 liter. If you take this 1 liter in a measuring cylinder, this amount of water, it will remain same, 1 liter. Its volume will not change. But the gas, it will change. How it will change, I will explain to you. Let's see, you have one box and you have how many particles? Let's say you have 4 gas atoms. Now, whenever they are in this, so they will spread and they will take the space of all the container. If you want to find the volume of the gas, so you have to find the volume of the container. Whatever the volume of the container, that will be the volume of the gas. In other words, we can say volume of a gas equal to volume of container. Now if I will take these four atoms in a big container, so again these four, they will take the sides, then they will cover all the, you can say, the container. Now again, the volume of a gas equal to volume of container. Now this container volume is more, so the gas volume also become more. The number of particle is same like a small container, but gas always take up the space, all the space available in the container. So you will take, if you want to take the volume of the gas inside a container, so you will take the volume of the container, that will be the volume of the gas. If you talk about the shape, the solid, they have fixed shape, their shape is not changed. But if you talk about the liquid, they take the shape of a container. For example, if a liquid in a beaker, so it will take the shape of a beaker. If a liquid in a jar, it will take the shape of that one. If it is in a glass tube, it will take the shape of a glass tube. So the liquid will take the shape of the container in which you kept. And the same goes with the gases. The gases also take the shape of the container in which you will keep them. After that, their density. Density means, if you see the formula of density, density is mass over volume. It means that how dense, or you can say how, in simple words, how heavy something is. So the density of a solid is higher. Why? Because in the solid you have more particles at one place. On a small area you will find more particles. In liquids, on the same, you can say, space, you will find less particles, because in the liquid the particles are away from each other, and in gases they are far away from each other. So gases have very low density. So if you talk about the density, solid has the highest density, then you have the liquids, and then you have the gases. After that, the next, known as compressibility, means how much you can compress them. If you talk about the solids, you cannot compress them easily. Why? Because already particles are closely packed and they don't have the space between them. Now, liquid, they also difficult to compress because they do not have the space, very small space, but you can ignore it. It means that you cannot compress them also. Gases, they compressible. Why? Because in gases you can see particles have a lot of space between them, so they can compress them. Some books you will find that liquids can be compressed little bit. That's also fine because they have a small gaps between them. But normally, if you take the in broader term, in solid and liquid, you will consider them, they are not compressible. So this is, they are compressible or not. After that, the this one, second last one, is diffusion. Diffusion means when two things are mixed with each other. You have substance A and you have substance B, so they come and mix with each other in such a way so they look like one, so that's known as diffusion. Now, if you talk about the solids, the solid cannot diffuse easily. Why? Because they do not have the gaps inside them. So how the other solid can come and take their space? It's not easy, or it's not, you can say, easier for them. Here they cannot come. But if you talk about liquid, yes, liquid have small gaps. So other liquid come and take the space, this one. So they have a diffusion, they have, but the diffusion is slow. But when we talk about the gases, gases diffuse easily. One gas can diffuse in another gas very easily. Why? Because they have the lot of gaps, lot of space for other particles. They can come and adjust themselves between them. So this is the diffusion happens. How diffusion happens. And then the diagram, if they want, they will ask you draw the diagram for solid, liquid, and gas. Sometime in the exam, they ask a question 1 mark. So you will draw them like this. For solid, they are closely packed. Liquid, they have a small gaps, and gases, they are far apart from each other. So this is sometimes they ask draw the diagram for the solid, liquid, and gas. So please tell me if is there any confusion. So you can ask me, then I will move to the next page. Please can confirm, Ahmed. Okay. Yes, Ahmed Yasir is okay. Okay. Now we'll move to the next, that is known as change of state. Now we studied that we have the particles, if they are closely packed to each other, they are known as solids. If they have small gaps, they are known as liquids, and they are far away from each other, so they are known as gas. It means that only the space between them giving the new state. For example, but the atoms are same. Whatever the atom here, the same atom here and same atom here. For example, if it is ice, it is water, and it is steam. If you talk about their type of atom, all they are same. But why they have different names and why they have different state? Because the distance between the particles. In solid, if there is no distance, so they are known as solid. If they have small distance, they are known as liquid. And if the particles are away from each other, so they are known as gas. It means that if we will increase the distance of a solid particle, they become liquid. And if we increase the distance more of liquid, so they can become gas. So it means that we can change the state easily. But now, how we can change the distance? That is by energy. It means that if you give the energy to the solid, so its particle, they can move away from each other little bit, so that's become liquid. And if we give the energy to liquid particle, so they move more apart from each other, so they become gas. So by giving the energy, we will convert solid into liquid and liquid into gas. So which energy we are giving them, that is known as heat energy. In other words, if you will heat them, so you can convert solid into liquid and liquid into gas. So whenever you are giving heat to some substance, so this is known as endothermic reaction. It is known as endothermic reaction when heat is given to some substance. So by endothermic reaction, you can change solid into liquid and liquid into gas. So which reaction? Endothermic. But we know that if you cool down a gas, it can become liquid. And if you further continue cool down liquid, it becomes solid. It means it is a reversible. So when you are cooling something, it means you are taking out heat from it. So that process in which heat is coming out, so that is known as what? Exothermic reaction. So these are the two states by which we can say that it is endothermic or exothermic. Now, substance change their state from solid to liquid, then to gas, and then back again. So by, you can say, heating, you can convert solid liquid, more heating, liquid gas. By cooling, you can convert gas into liquid, and if you continue cooling more, so liquid can back to the solid. So now This process we can also give some name. Number one is evaporation. What is evaporation? It is a process when a liquid turn into a gas at range of temperature below the boiling point. For example, now you know that if you take a water in a container and you start heating it, so you will heat it at 100 degrees Celsius, the water start to boil. Why? Because 100 is boiling point for water. So this is known as boiling point, and this process is known as boiling. And when the temperature will reach 100, you will see that the water vapors going up, and water here before it was liquid, when it's become steam, it will become gas. So this is one process by which you can convert a liquid into a gas, that is known as boiling. And boiling always happens at a fixed temperature. For example, for water, the what is a boiling point? 100. But not only boiling is only method. Now sometime you know that you will put some water in the room, you are not boiling it. After some time you will find that the water is disappeared, there is no water. Why? Because water is evaporated. Without boiling, without heating, if the water will disappear, water will convert into water vapor. So this process is known as evaporation. This is known as evaporation. So this is the main difference between boiling and evaporation. In boiling, you can see the bubbles, but in evaporation, you will not see any bubble. Boiling happens on a fixed temperature, but evaporation can happen at any temperature. Because if you, for example, you wash your clothes, your mother wash your clothes in winter, when the temperature is low, they will also dry. And in summer, when the temperature is more than winter, again they will dry. So evaporation can happen at any temperature, but boiling happens in a fixed temperature. But our main, you can say, idea is here that when a liquid convert into a gas, so there are two methods. Number one is known as evaporation, or other one is boiling. So by two methods, the liquid can convert into gas. After that, you also know the, if you have solid and you convert into liquid, so this process is known as melting, known as melting. And if you convert the, now I will make for example equation here. You have solid, here you have liquid, and here you have gas. Solid to liquid, it is known as melting. Liquid to gas, it is known as boiling, or it is known as evaporation. In the same way, if you reverse it, all these are heating, or you can say endothermic. Melting endothermic, boiling endothermic, evaporation endothermic. Now reverse, gas to liquid. Okay, this is known as exothermic. The heat is going on, or you can say that it is from gas to liquid, and then you have liquid to solid. Okay, gas to liquid, it is known as condensation, and liquid to solid, it's known as freezing. But there are other names. Instead of condensation, sometimes they use word liquefaction. When a gas convert into a liquid, so that's known as liquefaction and condensation. So mostly they use word condensation, but if the word liquefaction comes, so no need to worry. It is the same about condensation. In the same way, when the liquid convert into solid, it's known as freezing, but sometimes they known as solidification. So both the same meaning. But sometime what happens, one thing convert directly from solid to gas without converting into liquid, from solid directly gas. So that is known as sublimation. And gas to solid again also known as sublimation. Both are known as sublimation. The example is you have carbon dioxide, dry ice, or graphite. If you heat the graphite from solid directly, it will convert into gas. So this is known as sublimation. From solid to gas, sublimation, and from gas to liquid, solid, also sublimation. But sometimes they use the word deposition also. Gas to solid deposition. That's also right. But for you, both are sublimation. Also right. It's easy to remember. Now you can see this one here. Now from solid to liquid, melting, then evaporation or boiling, then from here condensation or liquefaction, or from here freezing or solidification, and directly here sublimation, from here to here also sublimation. Is there any confusion in this page? Please let me know, then I'll move to the next page. Okay. Now again they are talking. Now this meeting, if the meeting will finish, so please go back to the same link and join again, because after 7 minutes we'll finish. Okay. Now if you talk about this page, again they are talking about that change of state. Now melting is what? Solid to liquid. Boiling means liquid to gas. Freezing means liquid to solid. Condensation means gas to liquid. Now, if you want to convert solid into liquid, so you have to give the heat. The reaction is endothermic. If you want to convert liquid into gas, also heat is absorbed by the substance, endothermic. Freezing means you're cooling down. It needs cooling. It means reaction is exothermic. Heat is going out. And here also heat is going out. For example, if you have a water, what is the melting point of water? 0. Boiling point of water, 100. Freezing point of water, 0. And condensation point also 100. Melting point, freezing point always same, and boiling point and condensation point always same. If anybody asks to you that the boiling point of water is 100, what about its condensation point? You say 100. If anybody asks to you, okay, the freezing point of water is 0 degrees Celsius, what about melting point? That is also 0. But only difference in melting, it is going from solid to liquid, and in freezing, it is going from liquid to solid. That is the main difference between them. After that, you have kinetic theory. The scientists gave a theory, and that is known as kinetic theory. And this question comes in the exam, that write some points or some postulate or some important points of a kinetic theory. Kinetic theory really easy. So they're saying that the kinetic theory of particle is used to explain how substance changes from one state to another. They're saying mainly the kinetic theory will explain us how a substance convert from solid to liquid and liquid to gas, or gas to liquid or liquid to solid. It will explain this one. How it will explain this one? They're saying that, for example, when a solid substance is heated, the particles they gain energy and then they start vibration. Now, for example, this is the solid particle. If I will heat this solid particle, these atoms they get energy and they start to vibrate and they push each other. And you know that solid they have a force of attraction between them. But when you are giving this heat, so this heat will make them move and they will make the force of attraction weak. So they will move little bit away from each other. So when they move little bit away from each other, so it's become liquid. And if you continue heating, so then what happen? Again, these particles they move, they get more energy and they move more away from each other. So mean force of attraction become less because they get the energy, so it's become gas. So this kinetic energy will explain that when a solid is heated, particle gain energy and start to vibrate faster. Eventually, finally, particle gain enough energy to overcome the strong force of attraction. Particles can now slide past each other. So regular arrangement of solid particles break down and movement becomes random. So it means they can move away from each other. The solid is now melted. It's become liquid now. And the temperature at which the solid melts is known as its melting point. The stronger the force of attraction between the particle in the solid, higher its melting point. It means if the solid particles they have more force of attraction, so it means that they need more energy to separate them. When you talk about this one, so when you heat a solid, the particle move away from each other, so then they are known as liquid. In the same way, when you have a liquid and you continue heating that liquid, so the liquid particles move more away from each other. Let's say before they are close to each other, now they move far away from each other. So this is known as the gas. In other words, you can say that in liquids, particles get more energy and they move away from each other. Whatever the force of attraction they have in between, so they make it more weak and they convert into a gas. So when a liquid convert into a gas, so that process is known as evaporation or boiling. In boiling you have bubbles, so all the things they boil at a fixed temperature. The temperature at which they start to boil, so that's known at its boiling point. So you need a lot of energy to boil a substance. So if you have a melting point, it is need less amount of heat, and a boiling needs more amount of heat, because in melting you are just making the force of attraction weak, but in gases you are boiling, you just almost finish the force of attraction. So now with the help of diagram down you can see that the process, see this one here. If you talk about in solids, they just vibrating, these known as vibration. Now they move further apart from each other, and then in gases they are away from each other. So here you can say from here to here it is known as melting, but from here to here it's known as boiling or evaporation. Is it clear? Can I move to the next page? Okay, so further here you can see when solid is heated, the particles vibrate faster because they gain more energy. Force of attraction becomes weak due to the rapid vibration. Solid particles and solids start to melt. Liquid particles more faster move, escape, and then convert into the gas. So this is how they convert from solid to liquid and liquid to gas. Now, heating curves. Now, when you are doing heating, so it means if you have a solid, you are converting into liquid. And if you continue heating, you convert into a gas. So this process you can represent or you can explain with the help of a heating curve. What is the heating curve? It is a graph. Here I will take the temperature and here I will take the time. On y-axis, you have the temperature and here you have the time. Here, so it goes like this. Like this. Now, I will explain to you. You will get the idea more easily. Now, for example, you have ice. In this container, you have ice cubes, small pieces of ice. Then you have a thermometer here. This is you have what? Thermometer. And this one you have ice. And here you have a sprit lamp. You are using for heating. Now, let's say that before heating, the temperature is, let's say, minus 20 degrees Celsius. Before heating this one, the temperature is minus 20. When you start heating, what happens? The temperature start to increase. So when temperature start to increase, it's become minus 15, it's become minus 10, it's become minus 5. Now it's increasing and then becomes 0. So when temperature becomes 0, you can see in the thermometer temperature become now 0. So you are still heating. According to this heating process, after 0, temperature should become 5, 10, 20. But now you will feel that temperature is not increasing. You are still heating it, but the temperature is not increasing. The question comes, so if the temperature is not increasing, where the heat is going? Because continuously you are heating it. The answer is that the 0 is the melting point of ice. When any substance reaches to its melting point, so its temperature will not increase for some time. Why? Because now the heat which you are giving to the ice, it is using to convert, to change ice into liquid water. When all the ice will become water at 0 degree ice will convert it into 0 degree liquid water. So then again temperature start to increase. Then it will go to 10, 20, 30. When it will reach to 100, at 100 once again the temperature will not increase more than 100. You are still continuing heating. Where the heat is going? Heat is going to change liquid into gas. So this is how a heating curve acts. Now we'll see here, heating curve slow changes in temperature of a substance as it is heated. The temperature rise as the solid heats. See in the photograph, the top of the next page, you will see it. The curve flatten when the solids start to melt. The temperature remain constant while the solid is melting. Heat energy is used to overcome the force of attraction between the solid particles. Breaking the force of attraction, endothermic, it absorbs the heat during the change of a state. The temperature start to rise again and the solid particles turn into liquid. Then the curve flatten again, and while temperature the liquid is boiling, heat energy is used to overcome the force of attraction between the liquid particle. Now I will explain to you. Maybe you have confusion now, but I will help with the help of diagram. Just wait. This is a diagram. Very easy. Now here you have ice cubes. You start heating them. So let's say here the temperature is minus 25 degrees Celsius. When you're heating them, temperature is increasing, increasing, increasing. But still, the what is the state of the ice? Solid. Then this is 0 degrees Celsius, melting point. When melting point reach, you can see temperature is not increasing. This straight line shows that the temperature is not increasing. So where the heat is going? Heat is converting solid into liquid. When all the solid become liquid, mean ice become water here, then again temperature start to increase. And when it will reach here, again temperature will not increase. Why? Because boiling point came. When boiling point came, the heat is used convert liquid into gas. And the gas, now it's become gas now. Here it has more temperature. You know that steam always have more temperature than 100. So it is a heating curve. So this curve is known as heating curve, which is showing the process of heating. So few things you have to understand. When the line is straight like this, it means temperature is increasing, but the state is solid. During this flat line, it means temperature is constant. Temperature is constant. It means not changing. So where is the heat is going? Heat is converting liquid into, sorry, solid into liquid. So it means that in this place here, you will find both. You will find some ice and some liquid together. But when the line again becomes start to increase the temperature, it means now all the ice become liquid and temperature increasing again. And here in which state of matter it's here? Liquid. Again here when boiling point comes of any substance, so then again it is become straight. And why? Because liquid is converting into gas. In this area, you will find both state, liquid and gas together. But after them, again, if the temperature start to increase, it means now all gas. So this is how a heating curve acts. So if in the exam, let's say I will give you a question. There is a substance A. Its melting point is 10. Its boiling point is 120. So draw the heating curve for this one. Very simple. You will draw like this. You will make it straight like this. But you will not, when you will make it straight from here like this, here you will write 10 degrees. You will make it straight, then again start to increase. And when it's become straight again, so then what you will write here? 120. Because this is melting point, this is boiling point. And again, you will make it up straight like this. So this is how to draw a heating curve for any substance. So for that, you should know only melting point and you should know the boiling point. But keep one thing in your mind. So this, can you see this one? Length from here to here, this is melting process. This length should be less than this length. This should be always more and this always less this length. Why? Because boiling takes more time and more energy. More time and more energy. And melting take less time as compared to boiling and take less energy. So this line, this timing you can see here, it should be different. Please tell me any confusion about heating curve. Is it clear?
Yes.
Okay. Cooling curve is a opposite to the heating curve. Very simple. For example, if I will make a diagram for you, it will be like this. See here. When we draw the heating curve, we draw it like this. We went from here like this, then we become like, sorry, we become straight, then we become again like this, then we become straight, and then we become like this. So here it was heating curve. Cooling curve is opposite. So you start from higher. Here it's a gas. When you cooling it, so it's known in this here what you have liquid plus gas together. Then here you have liquid, and here again solid, and then this one. So here again, before what we write here, boiling point. Here we write condensation point. Here what we wrote before, melting point. Here we write freezing point. Everything is same. If I want to write for water, so I will write here 100 degrees Celsius and here 0 degrees Celsius. And the same thing again, the length here more as compared to length here like this. So this is a cooling curve. It is opposite to this one. So this is exothermic reaction. Heat is going out. You have a gas, you will cool down it, so it will become liquid. Again, you cool down liquid, becomes solid. So the point where it will start to convert into liquid, it's known as condensation point, and the point where it start to freeze, it's known as freezing point. So it is like a opposite to heating curve, the cooling curve is. Is there any confusion in this? Please let me know. Okay. Now we'll talk about the effect of a temperature on pressure on a gas. First of all, before we'll study that what is the effect of a temperature on a gas, we should know pressure of a gas. What is the pressure of a gas? Very simple. Let's say this is a container. In this container, you have gas particles. These gas particles, you know that they are always in random motion. When they are in random motion, they collide with the wall of the container and they also collide with each other because always they are moving. So when they collide with the walls of the container, they apply a force on the container. So this force create a pressure. That pressure is known as gas pressure. In physics, maybe you studied that. What is a pressure? Pressure is force over area. When you apply a force on an area, it is known as a pressure. So when gas particles hit the walls of the container, so they apply a force and that force create a pressure. So when you have, let's say, 100 atoms in this container, so the total pressure of these 100, it is known as gas pressure. So it means that the gas pressure depends on what? That how strongly, how hard they hit the walls of the container. Number one, that depends how hard they collide, sorry, with walls. Number two, how often. How often means how many times they collide. If they collide again and again and again, so more pressure. And they move faster. If they are moving faster, they hit faster. And when they hit faster, hit stronger, more pressure. When they move faster, they collide more and more, so more pressure. So it means that if you increase the speed or the kinetic energy of the gas particles, so they apply more, the gas pressure automatically increases. In other words, gas pressure depends the kinetic energy of the gas particle. If they are moving faster, so it means that the pressure will be more. How you can increase the their kinetic energy, how you can increase their speed with the help of temperature. If you heat any particle, it start to move faster. Its kinetic energy start to increase. So whenever you heat a gas, so its particles start to move faster. Their kinetic energy increases. And when their kinetic energy increase, they hit the wall of the container more and more. So when they hit the walls of container more and more, so the gas pressure increase. So this is how the temperature affect a gas pressure. We can see in now gas particle move in a straight line until they collide with other particles or they collide with the walls of the container. The size of the particle is much smaller than the distance between these particles. Therefore, most of the volume of the gas is empty. They're saying that if you talk about the gas, so the particles are away from each other. So this is the total volume of a gas, but the most part is empty. Gas particles move faster when they are heated because they gain more energy. Due to their rapid motion or fast motion, gas particles collide more with the wall of their container. The gas pressure results from collision between the gas particle and the wall of the container. An increase in temperature causes collisions to happen more frequently and pressure rises. So this is the reason why increasing temperature increase the pressure on a gas. Any confusion? Okay. After that, you have diffusion. What is diffusion? As we discussed that diffusion means two different substances, they mix with each other. So they mix with each other, so they are known as diffusion. This process is known as diffusion. For example, when you are using a perfume, for example, you are using a perfume and you enter in a room. So that's, let's say this is the room. You just enter from here. After some time, a person who is sitting here, even you are standing here, he can smell the perfume. Why? Because the particles of a perfume, they mix with the air particles and they move here. So the mixing of perfume particle with the air particle, it's known as diffusion. One other example, when you come to your home and you just enter your house, if your mother is cooking something in the kitchen, you can smell it even you enter your house. This is also due to diffusion. The smell particles, they mix with the air and they spread all over around it. For example, you have a water in a container and you add few drops of a ink inside it. After some time you will find that all the water become the color of the ink. So this is also known as diffusion. So diffusion means that mixing of two particles with each other. But if in the exam the question come that define the diffusion, so you will say that the particle diffuse from area of higher concentration to the area of lower concentration. For example, let's say when you are enter in the room, so perfume particles, they are more here, and here in this area where your friend is sitting, there is no perfume particle. So the number of perfume particles or concentration means numbers. Number of perfume particles, it is more here and here it is less. So from higher concentration, the perfume particles will move towards lower concentration. So when the particles move from higher concentration like here to the lower concentration like here, so this is known as diffusion. The random collision between particles are responsible for the diffusion. Why the particles diffuse? Because they collide with other particles, so they can diffuse. Diffusion is in liquid is much slower than in gases. Why? They're saying that if you have a liquid and you have a gas, for example, you have two liquids, liquid A, then you have liquid B. If you mix them, their diffusion will be, let's say, take 1 minute. And if you have gas A and you have gas B, if you will just leave them together, maybe they will mix in 30 seconds. So it means diffusion in gases is faster than the liquids. Why? Because the force of attraction between liquid particle, it is more. So it will not allow them easily to move. But in gases, the force of attraction between the particles is really less or no force of attraction. So they can move towards other gas very quickly. So the diffusion in gas is always faster than the diffusion in liquids. After that, solid particles do not diffuse because the strong force of attraction between their particles. Solid like sugar must first dissolve in water, then it will diffuse. So if they are saying that, if somebody will say that why the sugar will mix with the, why diffuse in the water, you will say that first sugar will dissolve itself, become liquid, then it will mix in the water. So this is the how, what is the diffusion. They have given the example bromine here. Bromine gas is a brown gas, is separated from air particles with a cover slip. So here, this is a cover slip, means like a paper. This is one separate mailing cylinder. This is one separate. So they are over each other and separated by a paper. And here you have bromine, and here you have normal air. Bromine is a brown color. You can see easily this is brown and this is colorless. But when you remove this paper, so the bromine start to come down and they start to mix. After some time, you will find that all the color become brown. It means that bromine diffuse with the air. So this is known as diffusion. Any confusion? Please confirm so I can move the next page. Okay. After that, you have the rate of diffusion. Means how fast a diffusion happens. Now they're saying that how fast a diffusion will happen, it depends on some things. The main thing, it depends on temperature. If the temperature is higher, diffusion will be higher. If the temperature is lower, diffusion rate will be lower. Why? Because at high temperature, particles move faster. If they move faster, they diffuse faster. At lower temperature, they move slowly and they diffuse slowly. That is the main thing. After that, the mass, or in some word they use the size. Size means the mass. How heavy the particle is. If the particle are lighter, lighter mean less weight, so diffusion will be faster. Diffusion will be faster. And if the particles are heavier, particles are heavier, then diffusion will be low. You can see here the example. I will explain to you and you will understand this one. See, they have taken two, ammonia and hydrochloric acid. Now, what they did, they took a one cotton piece, they dip inside ammonia, they keep it here. And they took another piece of cotton and they dip inside HCl, they keep it here, and they close the tube. Now, what will happen? The ammonia particles, they start to move. Here, they also start to move. Now you can see that ammonia particle, they cover more distance as compared to the HCl particle. In other words, you can say the HCl particles are moving slowly as compared to the ammonia particles. Why? Because HCl particles are heavier than ammonia. Okay, how we will know? We can find their mass, mr. So HCl is what? For example, HCl, you have H, how many atoms? One. What is atomic mass of HCl? H is one. Then chlorine, how many particles? One atom. What is atomic number? Atomic mass 35 point. So if you add them, it will become 36.5. So this is the mass of the HCl. Now find for ammonia, nitrogen, how many particles? One. What is the, you can say, the atomic mass of ammonia? That is 14 in periodic table. 14. Then you have hydrogen. How many particles of hydrogen? 3. And what is the atomic mass? 1. So it will 3, total 17. So which is heavier? HCl. So HCl is moving slowly. Why? Because it is heavier. Ammonia is moving faster because it is light. So particle with lower molecular mass diffuse faster, like ammonia. Use use the method to separate mixture of gases. This is also when there are some gases, they also use this method. HCl they is faster, so it is moved slowly because it is heavier. So in the exam, sometime they give a question. We will see in the past paper. So they will tell you that, for example, they'll say A, they will say B, and they will say C. They will say where they meet with each other. You cannot say A because that A means that it is moving faster. You cannot say B because it means the B means that both move at the same speed. The C is the answer. So like this, that we have to tell that how they move faster and slower. Is it clear that how to find the mass of one substance and then you can see which will move faster? Is it clear?
Yes.
Okay. Now these are the past paper questions, and we, you can say, I classified for you, and at the end of every lesson, inshallah, we will give, I will give to you this one. Now see here, for example, they give a question here that diagram show, sorry, the diagram shows the diffusion of hydrogen chloride and ammonia. We just did now. The hydrogen chloride mean HCl and ammonia mean NH3. So here, this is ammonia part and this is HCl part. So now they're saying that the gases are given off by solution at the each end of the tube. When hydrogen chloride and ammonia mix, they produce white. When they mix together, so they will make ammonium chloride, NH4Cl. This is ammonium chloride. It's like a white color. Now they're asking where they meet with each other. They cannot meet A because if they meet A, it means HCl came till here and ammonia just covered this part. It means that HCl is moving faster. No. At B, same, it's moving faster. No. C means they came at the same speed. No. Answer is D. Why? Because ammonia is moving faster than HCl. So this is the right answer. Did you get it? Now, this is the explanation for this one, why this is the answer. So you can see here, the rate of diffusion is depend on molecular mass. A molecule with a smaller molecular mass will diffuse faster than the heavier one. Since ammonia is only 17 and hydrogen chloride is 36.5, so ammonia will move faster and answer is D. So this is, every question has the answer and with detail. For example, if you go to the next page, you can find this one. Here the diagram shows how the arrangement of particle changes when substance changes the state. You can see here directly, this is solid directly going to gas. So this process is known as sublimation. Here the detail also there. So inshallah, I hope you will enjoy when you solve these parts. Already solved, just go through all of them. So do you have any question regarding today's lesson? Please let me know.